everyone, this is Jue from University of Florida, and today's video is for the presentation of the course project of image processing and computer vision. The topic of my course project is moving object tracking using KLT algorithm. Now let's get started. The most direct and general way for we human beings to explore and get to know the world is using our eyes. We have learned a lot by just looking at the environment around us and the object we are interested in. What we have seen can help us to decide what should we do in such conditions. We are using our eyes every day, and as the science and the technology have been developing fast for quite a long time, the computer and the machines are now able to look at the world just like what we are doing all the time, but in their own ways. The real-time moving object tracking is an important research part in computer vision. It involves the knowledge in many fields such as mathematics, image processing, automation control, and pattern recognition, and it has been widely used in our daily life. For example, the UAV and the monitoring system and the Xbox One. Generally, the process to realize tracking is just the process to find out the position of the same object in the image sequence. If we can detect the region which the tracking target belongs to in the first frame, then the process of tracking the target becomes the process of finding out the matches, depending on some features in the sequential image frames. The key points in realizing real-time tracking are to first select good features to describe the tracking target, and then to design optimal algorithm of searching matches. According to different methods of searching matches, there are mainly 4 different tracking algorithms. And let me explain. Model-based moving object tracking is to first build a specific model for the tracking target using some prior facts, then using the model to do the matching, and you need to make sure to update the model when there are some changes. The feature-based moving object tracking includes the extraction of feature points and the matching of those features. Object contour-based moving object tracking. The basic idea is to describe the contour of the tracking target using the snake curve, and finally the area-based moving object tracking. This method extracts the area where the object appears at initial time, and this area is used to do the matching in the following image sequence. The motion of object can be described by the motion field in the 3-dimensional space, and if the 3-dimensional space is projected onto the 2-dimensional image plane, the motion of object will be represented by the distribution of the grayscale in the image. If we know the intensity of the image at time t and the intensity of the image after a period of time, then we can get this equation. And if we can solve delta x and delta y according to the given conditions, we can know how the object moved during the period of time. Among many of the optical flow methods, KLT feature points tracking algorithm is the one that has the best performance in terms of accuracy and real time. KLT algorithm assumes a feature window W and use the sum of squared intensity differences of that window as the measurement criterion to realize the tracking of feature points. The target of KLT feature points tracking algorithm is to calculate the translation distance, and here is the results. The process of solving delta x and delta y has been described clearly in my report, and you can also find it in many other documents. The motion of the target and the motion of the background are different to some extent. Using the information of moving pattern of the feature points inside the moving target to decide the position of the target in the next frame can help reduce the effect of the motion and the noises to the detection of the target. However, the number of feature points inside the tracking target is relatively small, and it is very likely to be not able to cover the entire target if we only use the feature points that locate inside the target. So the tracking error will be relatively high. In this project, I take the advantage of the region of feature points. Instead of just using the information given by the feature list, I keep track of the potential feature points and keep adding new points to the feature list to get a better tracking performance. In this study, the real-time object tracking application is developed using MATLAB. The sequential image frames and their corresponding feature position and value are the output of the KLT feature tracker code provided on this website. This is one of the input image frames. We can see it is two-dimensional grayscale image, and there are different lightning conditions. In this project, there are two examples that shows the performance of the simple KLT and the modified KLT. This picture shows the detection result in the first frame. The blue ellipse represents the region of feature points. After the detection of the target in the first frame, the rest work is to find the matches in the following image sequence. And let me show you the performances. There are two examples show the different performance of simple KLT and the modified KLT. We first read in the feature point list and the image sequence, set the parameters, and call the function to realize the tracking. Now let's run the code. As you can see, there are changes in the lightning condition, and also there are motions of the non-target objects. We can see that during the moving of the tracking target, the blue ellipse that represents the feature points is not able to always cover the tracking target. Now let's check the performance of the modified KLT. Also, you read in the feature list and the image sequence, cite the parameter and call the modified tracking function. The right points are the feature points that are associated with the tracking target. The blue points are new feature points, and the blue circles are the potential feature points. The red circles are the points that have not moved for more than time window long, and that means they are the points that are no longer feature points. As you can see, the blue ellipse can cover the tracking target almost all the time, and this means the performance of the modified KLT is better than the simple KLT. And that's all. Thank you for watching.